Consider the PV cell as drawn here. So it has the two terminals, V and I. The input is the incident solar radiation. So what is the power input and what is the corresponding power output that this PV cell is capable of? Gives you an idea of the efficiency, which is given by P naught by P in, which is equal to P naught at peak power. So what is the maximum power that the PV cell is capable of giving at any particular installation is this peak power PM. So we will call this one as PM, and this is what is the output of the PV cell by P in, and we know that PM is nothing but VM IM by P in. Now what is P in? We said that the standard insolation is 1 kilowatt per meter square. And P in is given by 1 kilowatt per meter square into area of panel. What is the area of the panel? Go back to the data sheet. The data sheet, look at this row, the cells. There are 6 into 10 pieces of the polycrystalline cell, which means 60 cells, and each cell having this area as indicated, 0.156 meter into 0.156 meter. So let us use this in our calculation to arrive at what is power input is. So going back to so you see that the area of the panel is 60 numbers of the cells, each having 156 mm into 156 mm area. So let us convert them to meters. So it is 60 into 0.156 into 0.156 meter square. This turns out to be 1.46 meter square. So P in is 1 kilowatt per meter square into 1.46, which is 1.46 kilowatts. Now the cell efficiency from the data sheet is given as 16.5%. Therefore, P naught, which is equal to PM, which is the max power, will be efficiency of the cell into P in, which is 1.46 kilowatt into 16.5 by 100, which is equal to about approximately 240 watts. Therefore, the cell efficiency, I'll call it as efficiency subscript cell, is given by the output power delivered by the PV cell to the incident input solar power. The output power at the peak power point is named as PM, we know that, divided by Pin. And what is Pin? Pin is nothing but insolation, which is given in kilowatt per meter square into area of cell, the total area of the cell or the cells. We shall use the symbol L for insulation into the area of the cells, which is area cell, like this, and therefore after substituting you will see that PM divided by L, which is kilowatt per meter square, into the area of the cells, will give you the input incident power. Or further, in terms of the peak power voltage and the currents, we'll have VMP into IMP divided by L into a cell. The L, or the insolation, is in kilowatt per meter square. The area of the cell is in meter square. So this is the cell efficiency. However, one should note that the module efficiency is not the same as the cell efficiency. Efficiency of the whole PV module actually is less than the efficiency of the cell. What is the difference between these two? Basically, it is in the area of the cell and the area of the module. Now, let us look at this difference. Consider a PV panel. This is actually a 6 into 10 cell panel. You see, each is a cell. This portion, as I am indicating with the mouse cursor, is a cell. There are 10 such in this column, and there are 6 horizontal. Now, if you look at a much more closer view, you will see that the cells, the cells have some space in between. The module is actually encapsulating all these cells. There are spaces at the rim. The rim itself is occupying some area. There are some spaces in between the cells. Now all these area are not effective area, and the solar insolation, even if it falls on this area, is actually not captured. Therefore, the entire module is actually having a bigger area, accommodating all these gaps and spaces, as compared to the pure cell area alone. And therefore, the module efficiency is definitely going to be lower than the cell efficiency. If you come back to the data sheet and have a look at the data sheet, here you have the cell efficiency, and you see that the cell efficiency is 16.5%, and whereas the module efficiency is actually 14.66%. It is so in all types of panels because the module area is higher than the pure cell area, and most of the time the peak power and all these other the peak power rating as mentioned earlier here are with respect to the pure cell area and pure cell efficiency. However, for practical purposes, whenever you are calculating for a given application, the module efficiency is a much more conservative and better value to take because you will be using the more practical efficiency.